Hey guys, today we're going to be creating a number sets foldable. So to start this, you should have a normal sized piece of paper, and we are going to complete a shutter fold, which we've done a little bit lately, so you should be familiar with it. You're going to take your piece of paper and fold it in half. So we would call that hamburger or vertically. Or if you're like this, it's horizontally. I don't know. So we're going to fold that in half. And then you're going to open it back up and you're going to fold the sides into the half mark. So it makes like a little shutter. And the right side, you're going to keep just like that. Typically we make like little flaps, but we're not going to make a flap on the right side, but we are going to make a flap on the left side. So here's how you're going to do it. To the best of your ability, we are going to find the halfway mark. So just look, where is the best halfway mark? So I'm just going to make a slice just right where I think halfway is, and I'm going to cut to the end of that fold. So right now I have 2 flaps. But I actually need 4 flaps on this. So what you're going to do now that you've found the halfway mark, you're going to cut the halves in half to the best of your ability. So you really want to try to get it as much in the middle as possible. I'm going to cut the half in half, and then I'm going to cut this half in half, and now I have 4 flaps. So that is the layout of our foldable for today. We're going to be talking about types of numbers today and hopefully give you a good understanding of what they are. So we're going to start at the top with a type of number that is called a natural number. A natural number. So these are actually probably the numbers that come most naturally to us. And when we open this flap, we have 2 sections. We're going to be putting the definition on the left, and we're going to be giving examples on the right. So natural numbers are the counting numbers. So that's going to be your definition. The natural numbers are the counting numbers. For example, count for me. If I ask you to count for me, am I going to start at -12, half? No, these aren't places we start when we count. When we count, we say 1, 2, 3, 4, 5, and so on. So that's exactly what natural numbers are. 1, 2, 3, 4, 5, and that just keeps going. If I were to naturally continue counting, those would be my natural numbers. The next type of number we're going to look at today is called a whole number. It should be a number that you're actually very familiar with. You use them all the time. You might actually be thinking to yourself, wait a second, didn't we just do whole numbers? Aren't those 1, 2, 3, 4, 5? And that isn't far from true. So there's only one huge difference between a natural number and a whole number. So let's discover it through this definition. The definition says, natural numbers consist of the number 0 and all natural numbers. Whole numbers consist of the number 0 and here, guys, I'm just going to start using the number sign. So instead of having to write numbers the whole time, the number 0 and all natural numbers. So whole numbers are natural numbers, or I should say natural numbers are whole numbers. The only difference is that it also includes the number 0. So when we count, we don't say 0, 1, 2, 3, 4. But for a whole number, that is what a whole number is. So for our example, 0, 1, 2, 3, 4, 5. Those are our whole numbers. And if we were to keep counting, those would consistently be whole numbers as well. So they are natural numbers and whole numbers. The only difference is whole numbers includes the number 0. All right, let's talk about a new kind of number. So we've maybe like hit on this just a tiny bit, but this is a number that you guys will be using like crazy in 6th grade. And these numbers are called integers. Integers. So integers include whole numbers and natural numbers, just like whole number included natural numbers. So what I mean by that is that integers are the set of positive numbers. So it includes this set of positive numbers, which means integers also include 0. So let's start with the definition like that. Integers are the set of positive whole numbers I'm going to use that number sign again. So far what we're being told is integers are a set of positive whole numbers. Well, here's your positive whole numbers. So that means integers and whole numbers have a relationship. But the definition doesn't stop there. So we have to continue. Then it says they're opposites. And 0. Now we know 0's included, except this says a set of positive whole numbers. Well, the truth is 0 isn't positive and it's not negative. It's just 0. So that's why we have to include the word 0, the number 0 here. Integers are the set of positive whole numbers, 1, 2, 3, 4, 5, 0, and their opposites. So we need to understand what opposites are. So let's take a look in our example. If it includes 0 and positive whole numbers, that means, and I'm going to work down here below, so work here, go down a little bit with me. 0, 1, 2, 3, those are all integers, just like they are whole numbers. But it also includes their opposites. Well, the opposite of 0 is actually just 0 because it's not positive or negative. But the opposite of 1 is actually a negative 1. What that means is they are the same distance from 0 on the number line. So how far away is 1? 1. How far away is negative 1? 1. So that's their opposite. So negative 1 is also an integer. Well, so is negative 2 because that's the opposite of 2. And so is negative 3 because that's the opposite of 3. And this actually continues in the negative direction. So whole numbers, they're opposites, basically. We're going to be working a lot with negative numbers this year, and especially in this next unit. And then let's go to the last one. The last type of number we're going to be working with is rational numbers. You've actually been working with these all year. We've been working with decimals and fractions and numbers that aren't whole numbers, numbers that aren't necessarily just negative. So when we're looking at this, we need to realize these are numbers we already know. This definition is quite long, so you need to write a little bit smaller. So a rational number is a number can be written in the form of a over b or negative ab. So let me show you what I'm talking about. And this is just half of the definition, so make sure that you're writing a little bit small. A rational number, and I'm going to use that number sign especially since I have a lot to write on this one, is a number that can be written in the form, so when I said a over b or negative a over b, this is what I mean. A over b, or it could also be a negative number, a over b. Now notice I'm not saying anything about whole numbers here. It doesn't have to be a whole number. And then we need to explain these a's over b's and what they can be. So for a rational number, A is a whole number, so we're going to actually say where A, and we're going to put little apostrophes, or quotes, sorry, quotes on A. Where A is a whole number, and B is a positive whole number, with quotes. So let's think about what this is saying. If A is a whole number, but B is a positive whole number, what's the difference between a whole number and a positive whole number? Well, if we go back to our whole numbers here, I told you that 0 is not actually positive or negative. So if A can be any whole number, that means it can be 0 or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on. But B is a positive whole number that does not include 0. So that actually means B is really just a natural number. And this, I know I don't have a lot of room here, but I do want to say that it includes integers. So let's take a look at some examples of this, which change quite dramatically from our other examples, but because this can include negative fractions, negative decimals. It can also include all of the integers, whole numbers, natural numbers. So let's just start with an example, -5, 6. And these aren't necessarily in any order like I kind of ordered the other ones. 1.5 or 1 5/10. You could have just -4, which is actually just an integer, but it's also considered a rational number. It's more specifically an integer. So 0 actually works here. 0 can be written in the form 0 over 10. Well, 0 divided by 10 is 0, so that actually works. You can have the mixed decimal 3 and 45/100ths. You could also have an improper fraction like 28/4. Well, 28/4 is really just 7, which is a natural number or a whole number. But because I can write that in a fraction form, it means it's also a rational number. So these all have a relationship that kind of matches. It could also be something crazy like this mixed negative number, 7/8. This number right here is not an integer because of this fraction. If that fraction was gone, this would be an integer because it's the opposite of a 6. But since it has this 7/8, it's only a rational number and not an integer. So these are the types of numbers we're going to be working with like crazy, and you guys need to know these names of numbers. And they all do have a certain type of relationship. So on the right side, we're going to represent these using a Venn diagram that's a little different than your normal Venn diagram. So let's title this side number sets. So these are kind of sets of numbers. Natural numbers is a type of number. Whole numbers are types of numbers. So we call these number sets. And then in here, we're going to have a Venn diagram. Number sets Venn diagram. That you can see that. Number sets Venn diagram. So inside this, we are going to create a huge Venn diagram to kind of understand the relationship of these numbers a little bit more. I think the relationship between natural and whole is very obvious. The only difference is that whole adds the 0. So I think that's pretty good. Also, integers is pretty easy to think about because it is whole numbers, but it also includes the opposite of the positive whole numbers. And then rational numbers get kind of funky for students, but these are basically any fraction or decimal that is non-repeating, non-terminating. So these are basically every type of number in the world except for some numbers that we call irrational numbers, which you will learn about in 8th grade math. So let's go ahead and open this flap and we're going to create that Venn diagram. So typically when you are told to create a Venn diagram, students would immediately maybe make a Venn diagram that looks like this, where you're comparing two things. In this case, sorry, that's kind of hard to see, but we're not actually just comparing two things, and they don't all have exact similarities and differences. So I'm going to kind of explain what that means. So we're going to start with rational numbers. So I'm going to grab my rational number color, and I'm going to make the biggest oval I can on the whole page. So I know some of y'all like to have perfection, so just try your best. And we are just going to make a huge oval here. So what I'm showing is that this side is the whole entire page basically is representing rational numbers. So this is my rational number bubble. You might be thinking, why in the world did I make it so big? But I hope that this will make sense in the end. And then very much to the side, I want you to just give some quick examples. So maybe the mixed number 2 and 5/8. Notice I'm doing this very close to the border, and that is a purpose. Maybe I have a -7 and 4/10. But I could also just have the number -7, which is an integer, but it's also a rational number. But actually for this, I think that's not a good spot for it. So I think I'll do -7.1. Let's just add that. I'll tell you why in a little bit. Over here, maybe I have the decimal 8/10. And then I'm going to kind of stop right there, and we can add more to it in a little bit. But these are rational numbers. Well, we also know that a rational number could be a negative whole number. So, or the opposite of a positive whole number. So I'm going to grab my integer color, and I'm going to make another bubble. And I want you to make it as kind of close to that other bubble as you can, leaving a little room, but, you know, kind of follow my example. We're making it a pretty large bubble. And we're going to call this integers. Notice that my integer bubble is completely inside the rational number bubble, and that's important because rational numbers include integers. It says right here in your definition, includes integers. So I don't need to make this bubble outside or just partially in rational numbers. I need it to go fully inside them because all integers are also rational numbers. What's not true is that all rational numbers are integers. So you have to go from the inside out. So if I want to give some examples, and again, we're working on the outside, I could give something like -28. This is actually a better place for -7. It wasn't as good in here because this is a rational number, but it's also more specifically an integer. I could do -3. I could do something crazier like -125. Now notice I'm only putting negative, the opposite of negative, negative numbers here that do not have fractions or decimals, but it also includes that 0 in that whole number, but we're going to represent that with a new bubble. So let's go to the next one. We're going to add another bubble here, and this is going to be called whole numbers. And in this one, I'm actually just going to put the number 0. There are a lot more whole numbers than that, but the other whole numbers are actually also called natural numbers besides 0. So what this means is 0 is an integer. Look, it's in the integer bubble. 0 is a rational number. It's in the rational number bubble. But more specifically, that is called a whole number. And then let's finish this off with our natural numbers. Where's my natural number color? I don't know. So I'm going to do my last bubble here. Natural numbers. Remember, these are just your counting numbers. So 1, 2, 3, 4, 5. And then that goes on forever. If I kept counting, I would come up with 172 and then 563. These are all natural numbers. So some of you may be like, what is she talking about? So I'm going to show you a little something that I think will help clear this up a little bit and help hopefully have you understand what the relationship is between these numbers. So we're going to talk about ourselves for a second. So this is actually finished, but we're going to come back to it in just a second. We're almost done. And we're going to talk about ourselves and the fact that we all go to Medlin. You're either a student at Medlin or a teacher at Medlin. We are all part of the Medlin family. But what is also true is that we are all part of Northwest ISD. But everyone that's part of a Northwest ISD is not necessarily part of Medlin. So it makes sense that although we are Medlin, we are also in Northwest ISD, but Northwest is bigger than just Medlin. So some students in Northwest ISD do not actually go to Medlin. What's also true is that we all live in Texas. Well, there's tons of students that live in Texas that don't go to Medlin and that aren't in Northwest ISD. So even though Northwest ISD is in Texas, there are many students that aren't in Northwest ISD and many, many students that don't go to Medlin. And then the last connection I'm going to make here is we all live in America. So if we all live in America, think of all the students in America that don't go to Medlin. So in America, we are also in the state of Texas. We are in Northwest ISD and we go to Medlin. And although there are millions and millions of people in America, we are in America too. But more specifically, we belong to Medlin. So I hope this kind of clears up how natural numbers are whole numbers, but they are more specifically natural numbers. And integers, whole numbers are integers, but all integers are not whole numbers. And then rational numbers include natural numbers, whole numbers, and integers, but there are a bunch of rational numbers that are none of these. So they're a part of it, but they aren't the whole thing, just like America and Texas and Northwest ISD. So this is your foldable for the day. You can get it glued into your notebook, and hopefully that clears up number sets.